Hello and welcome to the Labor Day Limiting Reactant video. So this lesson, the 11th graders, you guys just did this. I don't think your seniors, when we did chemistry, I don't think we got to this. So this is going to be new to you. But it's not that difficult. So before we look at a chemistry example of a limiting reactant, we're going to look at a food example, just to help it make more sense. So if we read the little paragraph that says, so let's say you're making a very simple cheese sandwich, which is composed of, we have 2 slices of bread, so to make you need 2 slices of bread, and 1 slice of American cheese. Okay? If you have 8 slices of bread and 5 slices of cheese, how many sandwiches can you make? So let's see. Well, we have 8 slices of bread. I'm going to do this in a math way. And it takes 2 of them to make a sandwich. So using the slices of bread, you can make 4 sandwiches. Now, we have 5 slices of cheese, and it takes 1 slice to make a sandwich. And therefore, with the cheese that we have, we can make 5 sandwiches. Okay. Now, and you can picture this in your head instead of like doing the math, but whatever is easier for you. Okay, now, so the limiting reactant, or in this case the limiting ingredient, okay, is the ingredient or the reactant that limits the amount of product that you can make. Okay? So in this example, the bread, okay, is limiting, because with the bread we can only make 4 sandwiches with the amount of bread that we have. With the cheese, we can make 5. So the product, okay, that limits the reactant that limits the amount of product you can make is the limiting reactant. Okay? The one that you have enough of, or that's not the limiting reactant, is called the reactant that's in excess. Okay, so this one is, in this case, the cheese, and let me write cheese and put slices and bread. So in this case, the cheese is in excess, and the bread is the limiting reactant. When you do limiting reactant problems, it's important to know that the limiting reactant will be completely used up. So there'll be no more bread after you make your 4 sandwiches. And then the reactant that's in excess, there'll be some left over. Okay? So let's briefly, in sentences, define limiting reactant. The limiting reactant is the reactant, okay, that limits the amount of product that can be formed. And it's also important to know it's all used up in the reaction. Okay, so your limiting reactant will be completely gone in a reaction. Okay. Now, we're going to do some example problems, 2 of them actually, for limiting reactant problems. Okay, so it says, consider the following reaction. We have the reaction, and you have this many moles of aluminum, which is that product, okay, and this many moles of HBr, which is that product, okay. And the first question A, okay, is what is the limiting reactant? Now, in this case, I've actually made this a little simple for you because the reactant amounts are already in moles. They could very easily give you the reactant amount in grams, and then you have to convert them to moles. Okay? So, sometimes, okay, people are good. Let me move this magnifier thing out of the way, which I don't know why it keeps on popping up. So some people are good at just looking at the mole ratios and being able to determine the limiting reactant. Some people can't see it and they have to do it the long way. Alright, so I'm going to first show you the type of thinking that you can do so you don't have to do it the long way to figure out which one is the limiting reactant. So if we take a look at the amount of moles, the mole ratio that we have, for every 2 aluminum, you need 6 HBr. Okay. So if we look at the amount, we have 3.2 moles of aluminum. So we have more than the amount in the reaction. Okay, in the Downs equation. But in HBr, we have 4.96 moles of HBr, which is actually less than the amount than this. So you're increasing this, but this is staying below the mole amount in a reaction. So you can tell just by that this is the one that's going to be limiting. Okay. Now it's not always that easy. Okay. So sometimes it's just easy to do the math, and figure it out. So the work way to do it without like looking at the ratios and seeing if one is double and the other one is not. Okay. The work way to do it is to pick a product. Okay. And do the math for both of them, and the one that makes the less amount of product, okay, is the one that's limiting. So I'm going to pick this one here, HBr, because the second question asked me to use H2, or hydrogen gas. Okay, so I'm going to first start off, and let me scroll down a little bit so you guys can see. All right. So we're going to start, as we always do, 3.22 moles of aluminum, and we're going to put it over 1. Okay, then we're going to use our mole ratio. Okay, our mole ratio states that we're in the equation that we have 2 moles of Al, and for every 3 moles of product we're making, which is H2. Okay, and then if you do this math out, which I did already to save time, it's 4.86 aluminums cancel moles of H2. So I figured out how many moles of H2 we're going to make with the first reactant, and I'm going to figure out the number of moles of HBr. Same thing with HBr, figure out how many moles of H2 if we had this much HBr. So 4.96 moles of HBr. My pen is skipping over 1. Now in this case, the number in front of HBr is 6, and the number in front of hydrogen is still 2. And it's still 3, I apologize. And if we do the math, we get 2.48 moles of H2. Okay, now, this is the whole point. You'll see, okay, that this one here made less product. Okay, so that means that this is the limiting reactant. It's going to be all used up by the reaction. Okay, and then this is the reactant in excess. Alright. Now, the next question asks, what is the theoretical yield in grams for H2? Okay, when you're figuring out the theoretical yield, which is really just how many grams will be made, okay, you always want to use the limiting reactant. Because remember, it's the limiting reactant, okay, that determines, okay, how much product there will be. So we need to take the moles of H2 and then multiply it, as always, by the molar mass, which I believe is, if I can get this right, 2.016. And then if you do that, we need 3 sig figs. It's about 5 grams when you do the multiplication. So I'm multiplying that times that. Okay, good. Now, C is harder, okay? And we did not do problems like this in honors chemistry at all. So everyone's going to have to pay attention to this. So it says, for the reactant in excess, okay, how many moles are left over at the end of the reaction? Okay, so let's think about what we need to do before we actually do it. Okay, so we know, based on our math here, okay, that this many moles is going to of HBr is going to completely react. Okay, using that mole amount here, we can figure out how many moles of aluminum are going to react with it using mole ratios. All right, so we're going to start again. So 4.96 moles of HBr, and we're going to figure out how many moles of aluminum are going to react with that. Okay, by using mole ratios. For HBr, if we go back up to the equation, well, we have it here. The number in front of HBr is 6. We have it here. And the number in front of aluminum is 2. Okay. And if we do this workout, I'm not going to use any sig figs. We get 1.655333 moles of aluminum. Okay. And we know from the problem at the top that if you go back up to the top here, we know that we have here 3.22 moles. And what this is telling us here is that when you react this many moles of HBr, Okay, you need this many moles of aluminum. Okay, but we started with this. So to find out the amount that are, I'm sorry, wrong way, 3.22. To find out how many are left, we have to take the moles that we know are going to react and subtract. And when we do that subtraction, we get 1.57 moles left of aluminum. And then if they ask for grams, you could obviously convert that to grams by multiplying by the molar mass of aluminum, which is 28 point something, but it doesn't ask for that. Or 26 point something. Okay. Now, so let me just go through the steps of that again, talk through that again, to find out how much will be left over of the excess reactant. So you take the moles of the limiting reactant, which is here, and use the mole ratios, okay, to find out how many moles of the other reactant will react. Okay, then you know how much of this is reacting, okay, and you can subtract it from the total to find the amount that will be left over in the reaction. Now, they could ask this in grams, so you would have to multiply this by the molar mass in grams, and if they give you the gram amount, then subtract the grams. They could ask you in grams as well. I hope everyone sort of understands that process. There's one more problem that we're going to do, and so I guess we have time. I have 3 minutes to do it, so I guess we're going to do it. I was going to make a new video, but let's go. Alright. So, the AP exam absolutely loves particle diagrams. Okay? They love you to draw particle diagrams based on how conditions are going to change. They really, 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 really love particle diagrams. Okay, so we're going to be seeing, because the AP exam loves them, I'm going to be throwing them at you a lot. I actually am going to, because I'm going to run out of time. These videos can only be 15 minutes long. I'm going to upload this video and then make a new video for the particle diagram.